Hey everyone, we're about to start this video, which is just to get us warmed up and ready to go. We are working on some Algebra 1 concepts as we are still in the beginning phases of our Geometry Honors course. Can we graph lines from all three forms, okay? We're going to start off with graphing lines from point-slope form, okay? First of all, you need to know what point-slope form is. All right, so here's our example. I don't want you to take something like this, if you have to graph it, and change it into slope-intercept form first. That's a little silly. The only reason you should be changing the form is because directions might say to. If it doesn't tell you to change the form, then don't change the form. Don't do more than you have to do. So we're not being asked to change the form. We want to just graph it. So if you are in the habit that you would want to do this, make it look like y equals mx plus b, please pay attention to this. Okay, looking at the formula, okay, this equation that we use, this tells us x minus the x value of the point. Well, this says x minus 3. That means the x value of the point is 3. The point, we're working backwards, the point of my point-slope form is going to be positive 3. So I'm going to make a little note somewhere. Let's write that down. So 3 comma, well 3 comma what? Plus is the same as minus negative. So the y value should be a negative 5. So if you want to remember, it's always the opposite, sure. But really, it's always x minus and y minus the number that we're looking for. So plus is the same as minus negative. And these points really are translations. It took our line that started here and it moved it in all sorts of directions for us. So this is the point we're going to start at. So I'm going to go to the right 3 and I'm going to go down 5. 1, 2, 3, 4, and 5. And I'm going to put a point here and I'm going to make it heavy and dark so that I know exactly where I want that marked up. Okay? Now, I don't need to start at the y-intercept. So if you believed that that's what you needed, well, you're a little confused, and that's okay, and that's why I'm going over this. Now, this is your rate of change. A line has what we call a constant rate of change, so it's always going to have a slope of negative 5 over 2. If it didn't, if the slope changed, it wouldn't be a line, it would be a curve. So, or maybe not curved, but it wouldn't be linear. It wouldn't be a straight line. It would be bent, it would change directions, it would change slope, and you would have to graph in a different technique. So negative 5 over 2, rise is negative 5. That would mean go down 5. 2 is your run. That means go to the right 2. But if you don't have room, what are you supposed to do? Well, negative 5 over 2 is really the same thing as 5 over negative 2, right? So that means I can rise 5, 1, 2, 3, 4, and 5, and I can run negative 2, 1, 2. Again, rise 5, 1, 2, 3, 4, and 5, run negative 2. And there we go. Now I'm marking these points, but those are not the only points on the line. Those are just points that we are marking up, okay? Now I'm going to go ahead and I'm going to connect these points. I just want to find the straight edge, sorry. So I'm going to take this edge right here and use that to connect my lines. Now the more accurate you are, the better it will be for this activity, for this lesson, whatever you want to call this, because we're really trying to find out where these lines intersect one another. So you do want to make sure you're really, really precise. Now if you look and see, you see your y-intercept is not really perfect. In this case, you might be able to figure out that you're going up 5 over 2, well, up or down, depending which way you're looking at it. If you cut both numbers in half, that's really 2.5 and 1. We would never write a decimal really as a fraction like this, make that negative. I can go up 1, 2, and a half, and over 1. So that does tell me that that's 2.5. Now let's look at the next one, slope-intercept form. Now, if it's already given to us in slope-intercept form, get its name from slope and intercept. The intercept we are dealing with is the y-intercept. Okay? Like our x scales, because it's our independent variable to be nicely done, our y, sometimes we fluctuate and change, so sometimes it's just a little easier to work with the y-intercept. So I'm going to go down 2, and we'll talk more about that in Algebra 2. And then you apply your slope. So a slope of 3 over 5, well, that means I would rise 3, run 5, up 3 over 5, or I can also do down 3 and left 5, because 2 negatives make a positive. So down 3 and left 5, and there we go. If you are comparing work with a classmate, you might want to go ahead and label your intercepts. You might want to do something like 0, negative 2, then this is 5, comma 1, and this one here is negative 5, comma negative, where am I? So that's 2, negative 5. Okay, same idea over here. If you're ever asked to identify intercepts, I would definitely go ahead and write them as ordered pairs, because when you write something like y equals 2.5. If I wrote y equals 2.5, I'm really writing the equation of a horizontal line. So let's try not to do that, okay? And last, we have standard form. Now you might be saying, hey, I thought a was not allowed to be negative. Right, that's sort of our rule. And that's a rule in a lot of other books. But I warned you in class that not every book follows the same rules, or not everything will be really given to you in pure standard form. So if it looks like that, it's okay. We just roll with it. If you wanted to fix it, you could fix it, but I'm going to deal with this the way it is. A shortcut for graphing from standard form is to graph by finding the zeros. Not just the zeros. The zeros are another word for x-intercepts, but by finding intercepts. Okay? We want to find your x-intercept and your y-intercept. What does every point on the x-axis have in common? Every point on these axes, what do they have in common? The x-axis is really the equation of a horizontal line, right? We just talked about that. What would the equation of this horizontal line be? I mean, it's the x-axis. What's this equation? X-axis. My equation should be, pausing for effect, maybe you figured it out, it's actually y equals 0, because every point on it has y equals 0 in common. And the equation, similar idea, of the y-axis, okay? The y-axis is a vertical line. Well, what's the equation of this vertical line? We said if they have every point in common, we name it after that point. What point do they have in common? Think about that. They all have the point x equals 0 in common. So the y-axis, its equation's this. X-axis, equation's that. Now, we're really, on a different level, we're really solving by substitution to find out when does this line that I'm about to graph intersect this line, which is y equals 0. So when do they intersect each other? If you solve by substitution, that means you plug in 0, because that's what y equals, in there. Now what else is nice about it? If you fill in 0 for y, 5 times 0 is 0, this falls off. You could just cover it up with your finger, and then solve this little guy. Negative 4x equals 20. What does x equal? X equals negative 5. So you go to your x-axis, 1, 2, 3, 4, and 5. There we go, we have a point. We just said 2 points to determine a line, so I just need one more. My y-intercept now, y-axis, where does it cross it? Well, I'm going to sub in 0 for x. If I fill in 0 for x, cover that up. 5y equals 20, so what does y equal? Y equals positive 4. So 1, 2, 3, and 4. There it is. How do you write that ordered pair? Careful, put it 0, 4, and 2 points to determine a line. Well, that to me is the fastest way to graph from standard form, okay? By using these ideas, that's y-intercept, by finding the intercepts, you are quickly graphing the line by connecting those two intercepts, okay? Now I'm going to do one example with you, and the rest you'll have on your own. If you have slope-intercept form, I'm going to start up here at 1, and now my slope is 1/2. What other tricks can I throw at you? Well, you don't have to go up 1 over 2, because then you're just going to, I'm going to do that in one direction. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Sure, you can do that. But another option is, what's something else equal to 1/2? Can't I go down 3 and then left 6 and just get a point a little further away? Sometimes further away is better, and you just draw your line quicker. However, when I know I'm solving a system, I like to put a lot of points on there so I know I'm really, really precise. Next, you can graph this a few different ways. I'm going to graph by finding intercepts and kind of toying around with it from there. So I'm going to cover that up. 2x equals 5. Then what does x equal? Divide by 2. 5 over 2. How do you write an intercept? Should really be an ordered pair. 5 over 2, 0. 5 over 2 is 2.5. There we go. X-intercept plotted. Now our y-intercept, same idea. This is really the equation of the line x equals 0. If I fill in substitution, I use 0 for x. Now this is gone. 3y equals 5, y equals 5/3. 5/3 is really 1 2/3, so right about here. Now where do they intersect? Somewhere in there. Is it a nice ordered pair? Maybe not. Can't tell precisely what it is from this graph. Okay, algebraically, we're going to use some substitution. You may see this symbol, remember that from last year. This just really means that both lines get graphed on the same plane, okay? So kind of wanted to save it to talk about here. Here's one equation, 1 over 2x plus 1, and here's the other one, 2x plus 3y is 5, and we're going to use substitution right now. To substitute means you're going to plug in and replace a value with what it is equivalent to. So I already have y alone, isolated is another word. So I'm going to fill in for this y over here what that y is equivalent to, okay? Now that y, this is my yellow line, so I'm just going to use this over here. This is apparently equal to this, which is also right there, okay? So I'm going to fill that right in. So that means my work is going to look like 2x plus 3. Make sure we're using parentheses. 1 over 2x x plus 1 equals 5. Now, if you notice your equation, basically combine these two together. They're working in unison because we are trying to find out together where they intersect, what they have in common. When we are substituting, all right, you are finding the point where they intersect, but you'll only find x at first. Take that x, you fill it back in to find the corresponding y value. Distribute this 3 over here. I'm going to subtract that over. I have a 2. 3 over 2 plus 2. Well, 2 is really equal to 4 over 2. And 4 over 2 plus 3 over 2 is 7 over 2 x. How do I get my x isolated? Really, you should multiply by the reciprocal. I'm going to multiply both sides by 2 over 7. 2 over 7. You want to be efficient. These 7's reduce down to a 1. Those 2's reduce down to a 1. X equals 4/7. You do not leave your equation like that. This is a vertical line the way it is. This is the vertical line. Y equals 4/7. That is not your solution. You should not be writing something like that for your answer, okay? Your answer should be an ordered pair. This is your work, sure, but we have more to do. Now, I need to find what y equals when x is 4/7, so I'm going to fill it in right over here. You probably remember going through these steps, but make sure you understand what it is you're doing. Pay attention to the details I'm explaining. So I'm going to use this equation because y is already isolated. So I have 1 over 2x, which is 4 over 7, plus 1. Now reduce. Think smarter, not harder. This 2 and this 4 reduce. I'm left with a 2. 2 times 1 is 2, so y equals 2 over 7 plus 1, which we should really rewrite as 7 over 7, which means our y is equal to 9 over 7. Again, that is not an answer. You don't leave it like this. That is the equation of a horizontal line. You're finding a point, an ordered pair, a solution to a system of equations. So your answer is the coordinate point, ordered pair, which is the x comma y 4/7, which is less than 1, comma 9/7, which is greater than 1. So yes, we moved over less than 1 and we moved up greater than 1. So sounds good to me. That is your answer. And this is why you don't want to rely on graphing alone. Graphing alone, not that helpful when your point of intersection is not really nice integers, okay? So that was an example for you there, and hopefully that helped you out.